Hi, today we discuss about Endfire Array. What is mean by Endfire Array? We already studied about broadside array. In the case of broadside array, the direction of maximum radiation is perpendicular to the array axis. Whereas in the case of Endfire Array, the direction of maximum radiation is along the array axis. Here, the antenna elements are placed along the Z axis. Okay, that is the array axis. So what about the direction of maximum radiation? For the Endfire Array, it is along the Z axis. Then only we can say that the direction of maximum radiation is along the array axis. So this is the radiation pattern. Then next we can check how we can draw this radiation pattern. For that, we want to find the maxima, minima and the grating down. Okay, so we can say that here the direction of maxima radiation will be along the array axis. So we can say that the direction will be along the positive Z axis and negative Z axis. So value of theta will be 0 and 180 for maxima of the radiation pattern. Okay, so at theta is equal to 0 and 180, you will get maximum radiation because it is an Endfire array. What is the theta? Theta is the angle from the Z axis. So along the positive and negative Z axis, you will get the maximum radiation. That means in terms of theta, we can say that at theta is equal to 0 and 180 degree, you will get the maximum radiation. Okay. So what is the condition for maximum radiation? At the maximum radiation, the psi will be 0. Then only you will get the maximum radiation. So you can equate psi to 0 and psi, we know that psi is equal to beta d cos theta plus delta. And the maxima will be at theta is equal to 0 and 180 degree. So substitute that, you will get psi is equal to plus or minus beta d plus delta is equal to 0. From that you will get delta is equal to minus or plus beta d. And you know that beta is equal to 2 pi by lambda. Okay. So you will get delta is equal to plus or minus beta d. Then next is we want to find the grating law. We know the normalized electric field equation En is equal to sin n psi by 2 divided by n sin psi by 2. We already studied the condition for maximum radiation in the broadside array. The same condition here also. The field will be maximum when numerator is 1 provided denominator not equal to 0. So we equate numerator to 1, that is sin n psi by 2 equal to 1. From that you can say that sin have the value 1 in the odd multiple of pi by 2. Okay, so you will get n psi by 2 is equal to plus or minus 2m plus 1 pi by 2. Here you can substitute m is equal to 1, 2, 3, etc. You can't substitute m is equal to 0. What is the reason? For m is equal to 0, you will get the major law. So except 0, you can substitute the other values. Then psi is equal to plus or minus 2m plus 1 pi by n. And here psi is beta d cos theta plus delta, and we know that delta is equal to plus or minus beta d. Okay, you can substitute at the place of psi, and you can rearrange that. That is cos theta is equal to plus or minus 1 by beta d into 2m plus 1 pi by n plus or minus 1. From that you will get theta is equal to cos inverse plus or minus 1 by beta d 2m plus 1 pi by n plus or minus 1. Okay, here we consider n is equal to 4 and d is equal to lambda by 2 case. And we know that delta is equal to beta plus or minus beta d. Okay, substitute the value of beta and d, you will get plus or minus pi. Substitute that in the equation, you will get theta is equal to cos inverse plus or minus 2m plus 1 into 1 by 4 plus or minus 1. Let's consider m is equal to 1. You will get theta is equal to cos inverse plus or minus 7 by 4 and plus or minus 1 by 4. When we check this value, plus or minus 7 by 4, it is not possible because for a cosine signal, the maximum value is 1. Okay, that here 7 by 4, it is greater than 1. So this value is not possible. We consider plus or minus 1 by 4 only. So you will get theta value is equal to plus or minus 75.5 degree and plus or minus 104.5 degree. Next we can check m is equal to 2. and you will get theta is equal to plus or minus 75.5 degree. Okay, like that. You can next find the minima. Okay, for the minima, the electric field intensity will be 0. So E is equal to 0. Then you can equate numerator to 0. Sin n psi by 2 equal to 0. And the sin value have 0 at the integer multiple of pi. From that you will get psi is equal to plus or minus 2m pi by n. And we know that value psi is equal to beta d cos theta plus delta. And delta is plus or minus beta d. Substitute that, you will get cos theta plus or minus equal to plus or minus 1 equal to plus or minus 1 by beta d into 2m pi by n. First we consider cos theta minus 1. What is cos theta minus 1? You can say that cos theta minus 1 is 2 sin square theta by 2. Cos theta minus 1 is 2 sin square theta by 2. So you can skip this equation. You can move on to this one. 2 sin square theta by 2. Cos theta minus 1 is 2 sin square theta by 2 is equal to plus or minus 1 by beta d into 2m pi by n. From that you will get sin theta by 2 is equal to plus or minus square root of 1 by beta d into m pi by n. Here also consider n is equal to 4 and d is equal to lambda by 2. You will get sin theta by is equal to plus or minus square root of m by 4. So substitute a value for m is equal to ranges from 1 to 4. Okay. From that you will get theta is equal to plus or minus 60, plus or minus 90, plus or minus 120 and plus or minus 180 degree. Okay. Then we can check the second condition, that is cos theta plus 1. Okay. What is the 1 plus cos theta equation? 1 plus cos theta is equal to 2 cos square theta by 2. So you will get 2 cos square theta by 2 is equal to this equation. Here we consider cos theta plus 1. So that can be written as 2 cos square theta by 2, that is equal to plus or minus 1 by beta d into 2m pi by n. And from that you will get cos theta by 2 is equal to plus or minus square root of 1 by beta d into m pi by n. Let n is equal to 4 and d is equal to lambda by 2. You can substitute and you will get plus or cos theta by 2 is equal to plus or minus square root of m by 4. Here also you can substitute value for m ranges from 1 to 4. You will get theta is equal to plus or minus 120, plus or minus 90, plus or minus 60 and plus or minus 0 degree. Then you will take the theta value that is common in both the cases. Okay, that is the actual theta value for the null points. Okay, so here theta is equal to 60, 90, 120 and 180. Here the theta value is 120, 90, 60 and 0. So common points are 60, 90 and 120. So these are the null points. Then you can draw the radiation pattern like this. The maximum radiation is along 0 and 180 degree. And the grating lobes are along plus 75 and minus 75, plus 104 and minus 104.5 degree. Okay. And the null points are along plus or minus 60 degree, plus or minus 120 degree and 90 and plus or minus 90 degree. Okay. That is 90 and 270 degree. You will get the null point. Okay. Then you can draw the radiation pattern like this. Next we discuss about first null beam width. Okay, we know that theta is the angle measured from the z axis. Let we consider theta 1. Theta 1 is the angle between the direction of major lobe and the first null beam. That is, this is the theta 1, angle theta 1. Okay, so we can say that first null beam width is 2 into theta 1. Okay, in this equation, here in between 60 and minus 60. Okay, that is a 2 into theta 1. And what is the first null beam width angle theta? Theta can be computed by this equation. We know that sin theta by 2 is equal to plus or minus square root of 1 by beta d into m pi by n. From that you can rewrite theta 1 is equal to 2 into sin inverse plus or minus square root of 1 by beta d into m pi by n. and you can substitute the value of beta, that is 2 pi by lambda, and here we find the general equation. That's why we do not substitute the value for n. Okay, and d. Then here we consider the first null beam width. So first null points occur at m is equal to 1. Substitute m is equal to 1. You will get theta 1 is equal to 2 into sine inverse plus or minus square root of lambda by 2nd. And we know that here the angle is measured in a radian. So sine theta is equal to theta. So we can say that sine square root of lambda by 2nd can be written as square root of lambda by 2nd. So instead of lambda by 2nd, you can substitute sine into plus or minus square root of lambda by 2nd. You can cancel out sine and sine inverse. You will get theta 1 is equal to 2 into plus or minus square root of lambda by 2nd. Finally, you will get theta 1 is equal to plus or minus square root of 2 lambda by nd, and first null beam width is twice of theta. You will get this equation. And we know that L is equal to n minus 1 into d. If L is very much larger, L is a long array, that means n is very much larger, you can approximate n minus 1 is equal to n. So L is equal to n into d. So instead of nd, you can substitute L. You will get the first null beam width as plus or minus 2 into square root of 2 lambda by L radians. Then you can convert it into degree by multiplying by 57.3. Okay. Then next we can check the directivity. Same as in the case of broadside array, we know that normalized electric field intensity En and psi is equal to beta d cos theta plus delta. Here also we can approximate sine psi by 2 as psi by 2. Okay. Let we consider here delta is equal to minus beta d, that value only. Then beta d into cos theta minus 1 is equal to psi. Substitute delta is equal to minus beta d. You will get this equation, beta d into cos theta minus 1 equal to psi. Substitute that in the normalized electric field intensity equation. So you will get an equation like this one. If you know the normalized electric field, you can easily compute the normalized power. Pn is equal to En square. If you know the Pn normalized power, you can easily compute omega A using this equation. If you know the omega A, you can compute directivity by this equation 4 pi by omega A. Then we can compute omega A. During the computation, you have an integral from theta varies from 0 to pi and this quantity. Here we go for the substitution as in the case of broadside array. Let z is equal to n beta d into cos theta minus 1 divided by 2. Then dz is equal to n beta d into minus sin theta d theta by 2. And also the limit is also changing. Z1 varies from 0 to minus n beta d. Okay. Then when we go for the integration, there is a function like that. Sin z by z the whole square. It is a fast decaying function. So here we use an approximation same as in the case of a broadside array. In the case of broadside array, the limit is from minus infinity to plus infinity. But here the limit is from 0 to infinity. Okay, for a larger value of array. Okay, so 0 to infinity sin z by z the whole square dz can be approximated as pi by 2. Then the directivity d is equal to n beta d by pi by 2. And finally you will get d is equal to 4 nd by lambda. We know that nd is equal to L plus d. Okay, if the array is very much larger and the array is very larger, then L that is L is greater than d. You can approximate it as d is equal to 4L by lambda. That's all. Thank you.